So what I am doing today, I am analyzing the MODBUS TCP packets. So here I am having my real terminal, serial terminal, which is capturing all the data sent by my microcontroller over the UART or serial line. So let us see. So these are the packet I am dumping here. So here is my code which is doing the dump. So I have a function called dump. So this function is actually dumping whatever packet, whatever data is received on the TCP IP socket. So here is my hardware setup. In the center I am having my Ethernet development board, which is having a STM32F4 series microcontroller and an ENC28J60 Ethernet controller. This is SPI driven chip. And from here I have connected a debugger, a standard ST-Link debugger, and here is my FT232RL, which is a USB to TTL or USB to serial converter, which is connected to the UART port for debugging. And here is my RJ45 connector, which I am connecting with a Ethernet cable, which is going to my router. And this is the entire setup. On the back we are having a 5-volt SMPS, which is powering the whole system here. And this board, development board, is sending debugging data through UART, which I am viewing on my serial terminal. And who is sending the data? I am using MODBUS master here. So this is a software for simulating a MODBUS master. Okay, so I have chosen a connection type. This is MODBUS TCP. I have entered the IP address of my device and the port number. So 502 port is a standard TCP port for MODBUS TCP IP MODBUS, and I have already established a connection, but my software, that means my firmware, is not sending any reply. That is why you are seeing this timeout message here, but I am able to receive the data. You can see this icon moving, that means serial terminal is receiving data. So whatever data is received in the socket for this instruction, for this function code, I am dumping here. Okay, so let us see. So what I have noticed here, that we are having a lots of zero in the beginning. Here we can see that we are having 1 2 3 4 5 6 some zero. So when I change this one device ID, for example, currently the device ID is 5. Okay, so I am getting 5 here. So when in case of a standard Modbus RTU interface, this is the first byte in the packet. But this is not the case with Modbus TCP. We are getting the slave ID in the middle, not in the very first byte. So why is this? We will analyze, and we can confirm the fact that it is device ID. Let us change this from 5 to 2 and keep your eye here. Okay, keep your eye here on the data that is flowing, and let us change it from 5 to 2. So you will see that from 5 it has been changed to 2. Here you can see 2. Okay, and after this device code we are having the function code as usual in case of the Modbus RTU also. So when I change the function, so right now the function is read input register. Let us change it to coil register. So the function code for read coil status is 1, so it should change from 4 to 1. So we can see from 4 to 1 it has changed 1. Okay, so we are all confirmed that this is standard Modbus RTU packet, but we are having some header prepended to it, that means in the beginning. So let us see what are these bytes, these extra bytes. So from here to here, at least 1 2 3 4 5 6, so we are having 6 extra byte. So I have consulted this website, that is hashstudios.com, and here we are having some description and differences between a Modbus TCP and a Modbus RTU. So in case of Modbus TCP frame structure, we are having what is called an MBAP header. So what is this MBAP header? This MBAP header stands for Modbus Application Protocol Header. So this is a 7-byte field. So this is the thing we are getting here. So they have included this slave ID in this MBAP protocol itself. So 1 2 3 4 5 6 7. So these 7 bytes are for this MBAP header. So it is having some transaction identifier 2 byte. This field matches a request message with its corresponding response. So then we have a protocol identifier which is 2 byte. When Modbus communication is enabled, the system always set this value to 0. So both this should be 0. And then we have a length field which is also of 2 bytes. So this 0 and this 6. So this is the total length byte. So this lower byte is 6. Okay, then we are having the unit identifier which is also called the slave ID, which is after this 6 2. This is the slave ID, and after we have the standard things like function code and data field, which is as usual to the this normal RTU frame, function code data field. So we are not having a CRC in case of Modbus TCP. Why we are not having? Because TCP is already a reliable protocol. It already have all those things inbuilt, and the TCP IP stack is taking care of all those things. Great.